Wind turbines wouldn't be able to withstand the worst conditions in the world without these integral bearing components, hard-turned and finished on a Bost machine like the one behind me. You might see a wind turbine every day on your daily commute, but you might not know, they look so peaceful from afar, but you might not know how many stresses and high forces are acting on the components inside of those wind turbines. As a result, they need bearings inside of them to keep them running every single day. That's why we've come to Thyssen at the bearing facility to find out exactly how they make them on a Bost machine. Now, Henning, we're here in front of these big fat bearings, but there are different types here. Can you explain what types they are and which part of the wind turbine they go in, please?
Yes, of course. On the wind turbine, there are 5 bearings. We have one yaw bearing, where you put the turbine in the right wind direction. Then we have another bearing, which is called the main bearing, where the whole star is turning round through. And we have 3 more bearings on each blade. These are called blade or pitch bearings, to have the blades in the right position. For example, when you have a huge storm, you can pitch out the blades, so you don't have any damage on the turbine then.
Absolutely. And talking about storms, it's not like these wind turbines work in kind of just a nice sunny day. They have to survive every piece of weather that happens in the place where they're put, right? So these are critical components. And exactly what type of bearings are they? Are we talking kind of cross roller, radial bearings? And how critical are they to keep the wind turbines running?
So we have ball bearings for the yaw and the blade bearings, and we have tapered roller bearings for the main bearing.
Yeah, so tapered rollers are those really strong that can handle lots of different directions of force, right?
Yes.
Absolutely. And Thyssen has been making wind turbines for a long time, but we're here at like what I've been calling it the big bearing facility here. It's called the Production Center 9, right?
Yes.
But this is a big bearing facility. These are big components. What size components do you make here, and what part of the machining process do these Bost machines execute?
So right here in TB9, we're doing blade bearings and main bearings up to 6 meters. Right now we see here these bearings have a diameter of 5 meters. At Thyssenkrupp Rote Erde, the bearings are made from the block of steel to the final bearing. At first they get forged, then they get rough turned. Heat treatment is very important for bearings, for the race weight, for the endurance. And on the Bost machines, we do the final machining of the bearing.
So to make sure that those wind turbines, when they get put in these very difficult, harsh environments,
yes,
that final machining process is probably the most important part of it. And on these Bost machines, you're finishing parts every single day. But it's not just a normal finishing process. We see behind me the discoloration from the case hardening on the material. What happens?
Yes, the raceway of the machines, of the bearings get hardened, as I just told, and we do the final machining on the hardened raceways. You use ceramic inserts, and on these machines, you can do that very good.
Absolutely. You need to hit that material with ceramic inserts, because there's no other way to cut it because it's so hard.
Yes. So the raceway is hardened, and you have to use harder inserts than the hardness of the raceway is to have it machined. Yeah.
So these wind turbines are handling extreme weather conditions. That means they need extremely precise components, and you couldn't do that without the 2 Bost machines behind me.